Yes, sir.
Good afternoon.
Good afternoon, sir.
Okay. Good afternoon, everyone. So let me share my screen. So we were talking about some Thevenin's theorem in the last class, right?
Yes, sir.
So where were we in the yesterday's class? We were doing some tug of war with some circuit yesterday. Did someone try with the dependent sources for Thevenin's theorem?
Yes, sir.
Yeah, Himkar, you are there?
Sir, done.
Yeah, one of your friend has got some example of dependent sources. I will like to share a pic of it at the end of the class. Okay. So since we are not able to directly apply the Thevenin's theorem, so what they have done is in the previous class we used some circuit here, right? What is the circuit which we have? So
Sir, we use the circuit from the superposition theorem,
yeah, very first
dependent
theorem,
sources one.
Yeah, last circuit in the superposition theorem examples. So I will just give the hint how he have done it, and we will just see whether that can be done here or not. Fine. So according to the analysis which we have, so what is the Thevenin's theorem supposed to be done is replace any complex circuit with a two-element circuit. Fine. So such that we can reduce the complexity of the circuit for finding the currents. In this following question, we took two examples. One is to find the current I naught in this branch, considering this as RL, or we also took an example that this we considered this as RL in the second case, but we could not come to a conclusion yesterday, right? Because the procedure was a iterative one and it was going to infinite equations. So continue, we are going to get continuous equations. Is 36 available? Are you there?
Yes, sir, I'm there.
Fine. Okay. And so the method which we want to follow is that since we are not able to find, suppose if this is RL, as in the first case we assumed, right? So when we have a when we want to find the equivalent resistance here, we can easily find with the shorting of this, because I naught was 0. We somehow we could have calculated the value of RL. What was the calculation we have done for RTH? We were okay with RTH, right? In the first case, in the previous problem, previous class. What was the value of RTH in the yesterday when this was considered as RL? What's the value of RTH? We have done this, right? We shorted this, we opened this, and we shorted this as well. We found some value of current, value of resistance, right? We assume that these two are in series with parallel with, right? Haven't we done that? Suppose if this is RL, right? Just like in the previous example, according to this question, we said that we use this Thevenin's theorem here, right? Was it not 36? We wrote the value of RTH yesterday. What was that for the case one? We have drawn resistor here are 3 ohms, 1 ohm. This was shorted, and this was a resistance of 2 ohms, 4 ohms, and this was A, and this was taken as B, right? So this was A, B, this is 1, 3, 2, and 4. how these two are connected. These two are connected in series. So we said that 1 is in parallel with 5 plus 4. So what's the value you got it as? 1 plus 1 parallel with 5. We wrote this some value here. What was that? 4 point?
29 by 6.
Hmm? 4.2 ohms or something. We wrote it, right? What is the equivalent of this RTH? Is that okay? 5 by 6, right? It was 5 by 6. So it will not be 0.2. What is the value you have?
4.8, sir.
4.8, right? So we got the value of RTH directly, but we were having problem with VTH, right? So what we have done with the VTH? So we are not able to find VTH here because of the presence of this value, right? Isn't it? So what did we assume? What were we talking is you assume some voltage here, fictitious voltage between A and B. I said you to assume it to be VAB, right? Such that I can apply KVL for this loop, but we could not end up with solution, right? So what shall we do now is, or what's the procedure in general we can follow for when you have a dependent source is, you assume a voltage source to be present here with some, not only voltage source, you can even assume a current source. You assume it to be some voltage here, 1 volt. So assuming that this is not present here, okay, there is no 5 ohms resistor, I want to open it and I want to connect a voltage source here. So what's the need? What is the need for having the VTH and RTH? What is VTH and RTH exactly? What is RTH? Is the equivalent resistance between these two terminals, this terminal and this terminal, right? So if I take a circuit of, if I connect a circuit like this on a breadboard, and if I connect a ohm meter here, okay, I can get the value of RTH, isn't it? That's what we are going to get here. It has 4.8 ohms, isn't it? So what is VTH now? What is VTH? You, instead of using a ohm meter, if you use a voltmeter here, what are the value you are going to get across these two terminals? Then you call it as VTH, isn't it? So let me share you a picture where this was explained clearly, right? So let me share that picture first. One second, give me a second. Yeah. Is this visible? Is the picture visible?
Yes, sir.
Yes, sir.
So, yeah. So you have a question here. See, for the circuit shown in the figure, the Thevenin voltage and find the Thevenin's voltage and resistance looking into the circuit. Right. This is a whole circuit, which was a complex circuit, and you have a resistance RL across AB. Is this okay? Is it so? What are the things you have in this example? What do you have in this example? How many sources you have? Are you there?
2 sources, sir.
Yeah.
Voltage source and a dependent current source.
Yeah. You have 2 sources, one voltage source 40 volts and a dependent source. What type of dependent source is that? It's a
Current dependent current.
current dependent current source, right? So you have arrow here, so you have a dependent source here, so you could represent it with current dependent current source, right? So now what are the things we have to find is to draw the equivalent circuit. So we know that what's the things we have to draw in it. How can we draw a equivalent circuit? Is just to replace the circuit with a constant, it's a equivalent voltage and a resistance, right? So across AB, we need to get only 2 elements. One is across AB, I need only RTH and VTH. So how do I find that VTH, RTH and VTH? So first, let us find RTH, or here you found it as VTH now. So let us, how do you find VTH first is, what's the condition given here? What's the dependent value is on I, the value of current that is flowing through this external circuit, right? So if I have a load resistance here, definitely the load resistance is to be connected in series here, right? Suppose if this is the equivalent circuit given, where will be the value of RL? It will be here, right? So the value of RL is being removed here. Let us assume that will be fine, right? This is a complete circuit now, right? So what's the first step in finding the value of RTH and VTH is to remove the second. Yeah, to remove the RL first, right? And how do you find value of VTH? Is the value of voltage drop across A and B. Now, when we are trying to find VTH, what's the first thing we do is we assume that the current is zero because there is no current flowing here. What are the current that flows here will be flowing through these elements, right? So since the current flows only in this closed path, there is no current that flows in the out of this circuit, right? So the current flowing here in this circuit, this becomes equal to zero. So now once the current becomes zero, what happens to this current current source? What will be the magnitude of this current source?
Zero.
Yeah, it will be zero, right? So what is the equivalent will be? The equivalent will become like this, right? See, if I make it equal to zero, when can I assume that the current magnitude is equal to zero? When can we assume that current magnitude is equal to zero? When it is replaced with the open source, right? So for voltage source, voltage to be zero, it should be replaced with a short circuit. For current source, to make it zero, you replace with the open source, right? So this will be the equivalent circuit, and we know that since there is no current flow in the resistor 6 ohms or 10 ohms with this open circuit, because this is already open, whatever the voltage that appears here, right, will be appearing across this plus minus terminals. Am I clear? So what's the value of VTH now?
40 volts.
Same 40 volts will be appearing across the terminals A and B, right? So this was the example given. I didn't conveniently eliminate the value of dependent source, man. 36. We didn't modify the circuit to be right. It was just like that. So we somehow we eliminated the dependent source here.
Yes, sir. I understood that.
Yeah. So now the value of VTH which we got here is 40 volts, right? This was fair enough, and this is okay because this analysis part is same for even for a normal circuit as well. But the problem comes when it comes for the form. What do you say? Finding the value of RTH. Now here comes the value. How you find the value of RTH? Okay, I'm sharing the same slide, I think. Okay. One second. Give me a second. Yeah. So this is a circuit. This is a procedure to follow to be followed for finding the value of RTH. So we got the value of VT. Is the screen visible?
Yes, sir.
Yeah. So since I got this directly from one of your friends, so I just displaying it here. If not, I would have kept it in a PPT as well. Fine. So how did they solve for this condition. So whenever you are when you are supposed to find the value of RTH, what's the first thing to be done?
Eliminate all independent sources.
Short circuit.
Are you able to hear me? What happened? Are you able to hear me?
Yes, sir.
Is the screen visible?
No, sir.
Oh, okay. Is it okay now? Screen is visible, right?
Sure.
Yeah. See, somehow only a few people are active. Have good attendance, 55 people, but anyhow 5 to 10 are in active, right? So please respond. We can't disturb the others, right? So that's the reason I'm repeatedly calling who are active here. Fine. Okay. So what we have to do in the yesterday's assumption, if we assume that this to be a current source, and since I replace the voltage source with a say with a short circuit here, what should I do with the current source? I should open circuit this, right? So the equivalent resistance could be directly given as 6 plus 10, that is in series here. But what's the problem here is we can't, according to the statement for Thevenin's theorem, the dependent sources has to be in the circuit or cannot be changed when they are with during the value of RTH to find the while finding the value of RTH. So what should be done now is, how can you find the voltage equivalent resistance here? See, the only method we have is to assume some source to be present across A and B, because all we want is just to find the value of equivalent resistance what we get here R A B, right? This here we want to get the value of RAB, that is a volt. If I connect a ohm meter, what is the value of resistance I am going to get? That I want, right? So what is the best methods to have the value of R? We know this, right? What are the best methods to evaluate the value of resistance? Is to find the value of ratio of V by I, right? So how do you get this V? Where do you get this value of I? We for this for evaluating the value of V R, what we do is assume a voltage source. We'll clear all this switch across the terminals AB, right? Across the terminals AB, just let me know where you have if you are unable to follow, right? Right. So across AB, I assume 1 volt of voltage source, right? So what you can assume any value of voltage, okay? Even if you are interested, you can also use any current source there. All our intention is just to find what is the amount of current that is being supplied if I have a 1 volt source. What happens if I use a 10 volt source? The current increases 10 times. That doesn't matter, right? Because the value of resistance is going to remain same with the ratio of V by I. So if I increase the value of V, definitely the value of current which you are going to get also increases proportionally, because the circuits are very linear and they are scalable, right? That's the properties we studied, homogeneity. So as this increases with, if I want to increase this voltage, definitely the value proportionally the current increases. So there is no problem even if I assume 1 volt or 10 volts, doesn't matter. Is that clear? So what will happen if I assume a voltage source here? How the calculations has to be done now? Suppose say that this is already existing circuit, right? This circuit is already is one which is already existing. So let us say take this circuit which is added now, right? Consider that this is added circuit. So what happens when I connect this voltage source here? The circuit formed will be like this, and let us assume some mechanism. Either say it as, all we are interested is to find the value of voltage and current flowing in this path, right? Or if I want to find the current flowing in these two here, what does it indicate? What's the need for doing so? Why we haven't done this for the other circuits, right? But why are you doing here when it is a dependent source is because the value of current, this dependent source is depending upon the value of current that is flowing in this branch. Whatever the current that is delivered by this source will dictate the value of current source here. So now what happens when the current source, this value changes, this current source value also changes. Fine. So to know that value, to know the value of current, how it defines, right? What's the proportionality at which the current flowing in the circuit is defined? We are assuming a voltage source here. Am I clear up to here?
Yes, sir.
So what we do next is we take this as a whole complete circuit, right? Whole complete new circuit, and what we do is we identify the nodes now. How many nodes we have? How many principal nodes we have? We have 2 principal nodes. So I take one as reference, right? I will take one as reference. Yeah. Okay. We'll consider this one node as reference and you assume it to be 0 volts, and the other one you take it as node A, or you say it as V node A, which is nothing but V. The voltage across at this node is V. And assume that the currents are leaving the node here. Let me give some number values here, which can be given as I2, I3, and I. All the we assume that the currents are leaving the node here. All the currents are leaving the nodes. That means the addition of all these will be equal to 0. So applying case nodal analysis, what is the thing we can do here is, so applying case nodal analysis, we can write this equation, right? Applying KCL at this node, what's the equation we have? Sum of incoming current is equal, or else algebraic sum of incoming and outgoing is equal to 0. Since I already have all the outgoing current, so the equation can be written as I plus I2 plus I3 is equal to 0. So now the problem is when you write these values of this equation is okay, right? So what's the next thing to do is this value of current, right? So what is the value of current I am going to get here? What is the I? I is the current that is flowing through 6 ohms resistor. And what is V by I2? What is the value of this I2? VA minus 0 by 10, right? That we wrote it as V by 10. And what's the current for this? This is a current source. It's already given as 0.8 I. So even I can write it as VA by the, I don't, since it's a current source, I can directly write it in terms of 0.8 I. Is this clear for everyone? Is the equation okay up to here?
Yes, sir.
Yeah. So by simplifying this, we can come to a point here where we can write it as a equation. What is that? V plus 18I is equal to 0. This is a equation with 2 variables. So taking LCM, we can get it as 18I V plus 18I is equal to 0. But we can write just like this. How did we write the equation for I2? How did you write the equation for I2? We wrote it as V by 10, right? Or V minus 0 by 10. That's what I write it as V by 10. So similarly for I can write the equation, right? I can even eliminate I by writing the equations in nodal form. What is the equation I can write for I? What is the equation I can write for I? It's by 6 ohms, right? Can I write this equation? Yes or no? Are you there? Okay. Aryan, it's okay, fine. So now when I can write this equation, what's the conclusion I can write for I here? What's the final equation I can write for I is equal to V minus 1 by 6, right? V minus 1 by 6. And we use this equation wherever you see the value of I. I have I here, I also have I here. So we can use it here wherever you have the I. So what's the equation finalize? If I substitute here in the equation, what is the final equation you get for voltage? we will get a voltage as V is equal to 3 by 4 volts. We get it as V is equal to 3 by 4 volts. What is this V? What is this value of V is? V is the value of voltage at this node.
చేసినప్పుడు ఈ స్క్రీన్ అనేది సెలెక్ట్ చేసుకోండి.
Right, 3 by 4 volts,
అప్పుడు
right?
మీరు స్క్రీన్ మీద ఏం చేసినా అది షేర్ అవుతుంటుంది వాళ్ళకి.
Right. So
ఇప్పుడు ఆఫ్ చేయక్కర్లేదు సార్, మీరు ఏదైతే స్క్రీన్ మీద పెడతారో అదే వస్తుంది. పీపీటీ ఉందనుకోండి, పీపీటీ నుంచి నేను ఐడియల్లీ క్లిక్ చేస్తాను అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఐడియల్లీ.
So now, okay, we got the value of V. So I think we have the equations where we can substitute the value of V to get the value of
అదే షేర్ అవుతుంది.
I and I1, right? So what's the equation I can get for I1? What is the equation we get for I? So I already have the value of I as V minus 1 by 6, right? Substitute the value of V. What's the value I'm going to get for I? What's the value of I we are going to get here? I is equal to?
మీకు అది వాళ్ళకి కనిపిస్తుంది సార్.
కానీ అక్కడ కర్సర్ వచ్చి అక్కడ
వస్తుంది సార్, వస్తుంది.
ఈ రోజు నాకు అదే అంటే రోజు అదే చూస్తాము.
నేను జూపిటర్ అంతా ఏం చేయలేదు సార్. పెడితే మంచిది అంటారు కానీ జూపిటర్ అయితే ఒక పక్క కోడ్ కనిపిస్తుంది, అటు పక్క ఇన్పుట్ అవుట్పుట్ కనిపిస్తుంది.
ఇంకా బెటర్ ఏం కదా?
బెటర్ ఇంకా.
So fine, let it be. So see, what's the value of I am going to get here if I substitute the value of V is equal to 1 by 3 by 4? I'll get it as V 3 by 4 minus 1 by 6. So what's the value I am going to get? What's the value you are going to get? 1 by 24, right? 1 by? Is that okay? Yeah, you're going to get minus here, right? Minus 1 by 24. So this value of magnitude, what's the magnitude I get here is this value as I is equal to minus 1 by 24, right? So what's the value of I which I'm sending into the circuit now? This will become positive value, right? What is this value of I1? Since the direction is reverse to I, this value magnitude will be, since these two are in series, right? This is a series path, right? The current remains same. So if I'm taking I, the direction of I in left to right as minus 1 by 24, the direction of current from right to left, we can take it as 1 by 24. So as we are talking, what's the value of RTH can be given as? RTH can be given as V by I1, right? So what's the value of V is 1 and what's the value of I is 1 by 24. So you get it as the resistance to be 24 ohms. So this is how we find the value of RTH and VTH. Is that okay?
Yes, sir.
Yeah, so what we are trying to do here, what's the need for making it to pump or use a pumped source here? Enduku ee source enduku vadutunam? So can I get the same value if I use the voltage source as 10 ohms, 10 volts here? Will that be okay? Can I get the same values if I substitute the value of voltage to be 10? Will there be any difference?
Same.
We'll get the same. Why? Because this, based on the value of V, this value of I changes and this value of this equation going to change, right? So once the two equations are going to change proportionally, see here, if I want to take it as V minus 10 here, instead of writing the I value as I is equal to V minus 10, when I use a 10 volt source here, then it will be same when I apply here, right? So proportional increase, there is a proportionality increase in the current as well as with the change in voltage. So when these ratios are changing proportionally, the value of RTH remains same. Even you can give a try for that. Assume that voltage to be 10 volts. So all we are doing is a reverse process. We don't know how this has to be handled, right? We don't know how this equivalent resistance has to be calculated. So what we are doing now, we are using a source and pump the current, and we take the magnitude of voltage and current which we are pumping inside and take the ratio that will be the equivalent across these two terminals. That's what we are doing here. We are least bothered about the rest of the parameters in the circuit when you have a dependent source. Am I clear? Am I clear? Now you got the value of RTH as 24, right? So it will be greater than 10 plus 6 here, right? See, sometimes you may even get less than 16 as well. Why? Now these two are connected in series, so I can get that resultant is more than 16, right? But in some cases, even you can get the value of RTH for some dependent sources less than 16 as well. So that doesn't matter now. You just, yeah, you're able to follow rule number 12. Fine. So is this okay? For example, for a dependent source. Now let us go back to our previous circuit where we were using this. Now this is the circuit we are assuming, right? Suppose if you want to find this thing now, suppose if I want to find the same VTH and RTH for this, we already found RTH. If you want to find VTH here, use the same procedure. Assume some voltage source here, right? And find the value of current. Since you can apply nodal analysis here as well. Consider one. You have two nodes or principal nodes. You can consider this as 1, 2, 3, and 4. You can take this as reference. Okay, and you can take this as node 1, node 2, node 3, and you can calculate the values of currents, and somehow you can get the ratio of voltage and current which you are having in this junction. That's it. That will give the value of VTH, and you can directly construct the circuit or Thevenin's equivalent circuit with RTH and VTH. So let us do this as a homework, or consider this as a homework, right? I will be happy to share if someone shares the answers by evening today. Can I expect solutions from someone by evening? Assuming a source here, just like as previous. I will post that in the group actually. That I will send that example which I'm using now, as I will send it in forward it in the group. Then that will be fine, right? Is that okay? 36.
Okay, sir.
24. Is Bhaskar available? Before Bhaskar.
Yes, sir.
Yeah. Are you able to follow, man?
Yes, sir. I'm following.
Huh? Yeah, I'm uploading the PPTs in CMS, man. I'm not able to see that. I have uploaded the whole unit, bunch of the unit as a single PDF. You can go through any of the classes. Yeah, Ananya, I said you to remind in the morning, right? Okay, fine. I will somehow I'll try to get question bank as well. Okay, so you can do some exercises problems from the question bank itself.
Okay.
Fine. So shall I move on to the next topic now? Or since the time is very less few, we go for solving one more example for the Thevenin's theorem itself. Okay, let us take this example. So please quickly just give me the values if possible. Is the screen visible?
Yes, sir.
So I'll just go with this. This is okay, right? So using Thevenin's theorem, find the current in resistor R2 of 2 ohms. Take down the circuit. Can you solve it? What's the procedure to solve it? What's the first step to do? All we need to find is only two elements, right? First is RTH, another is VTH. So how do you find the value of RTH and how do you find the value of VTH? So let me assign this as V1, 1 and 2. Okay. So how do you find the value of VTH? What should be done first? What should be done first? Remove RL, right?
Yes, sir.
First we have to remove RL. So let us redraw the circuit somehow in different manner like this. See, so what you are trying to do here is just eliminate. So eliminate this, bring this R2 outside. Both are same, right? These are, even if this circuit or this circuit, both are same, right? Are they both okay? These both are same, right? Are these both circuits same, right?
Yes, sir.
Yeah. So now, first step in order to find the value of VTH and RTH, right? So what's the first thing we have to do when it comes to find the value of VTH? First thing what you have to do, open this, right? Remove RL. What's the first point? Remove RL. So we are considering RL, that is as R2 as RL, so we remove it. Okay, so how will be the circuit now? When once I remove it, this will be the this will be the circuit. Circuit becomes like this, right? Now, where has to find the value across A and B, right? Across A and B. So now, how to find the value of VTH now? VAB, voltage across A and B. How many sources you have here? Two sources. One is 28, another one is 7, right? So what is the resultant we are going to get? Are they in series aiding or are they in series opposing? We know that
21. We'll get 21, sir.
we'll get
21 volts total source.
total source as 21, but the connecting points are not same, right?
Yes.
Suppose say if they are in series aiding or opposing, just like this, say if I have a connection like this, then I can say that they are aiding each other, right?
Yes, sir.
We can add them 28 plus 7, but even if I have something like this, then we can oppose it, say 28 minus 7. But the problem here is they both are in parallel lines. So what is the thing how can we identify the value here? But see, what's the primary condition we know or for parallel circuits is that the voltage in a parallel circuit should be same, right? Isn't it? So across these terminals, I can take this as A and B, right? Simply, instead of glorifying them, I can write this as A, B, right?
Yes, sir.
So the voltage potential between A and B should be same, right? If I connect a voltage source here, since they are in parallel, the voltage has to be remain same, right?
Sir.
So now the whatever the drop, see, since this is a source, this will be delivering one current, and this is another source. Let us assume this is delivering another current. So what's the condition I can make here, or a justification we can make here, is any voltage drop that is 28 minus I1 into R1 should be equal to 7 minus I2 R2. Is that okay? If I apply KVL, that will be the equation, right?
Yes, sir.
Applying the KVL loop equation, that will be the equation for this loop. I think you can find the values of I1 and I2 here. Can we find the values of I1 and I2? Is it possible? Because somehow I need to get the value of either I1 or I2 to get the value of to get the value of this voltage drop across A and B. So what happens if we assume what is the condition we can assume here? Is we assume that the current I1 should be equal to I2, because we don't have two variables there, right? We don't have two equations there, so only one variable we have is only one. That is, if I assume the loop current, the current in that loop should be same, right? And how many paths of currents we have here is only one, because A and B are already open circuited. So what are the current that flows, that has to flow in the circuit between these four elements? Two voltage source and two resistors. Am I clear? So what's the assumption we can write here, or what's the condition we can write here? We can write I1 is equal to I2 is equal to I. Why did you write this condition? Where are we writing, coming to this conclusion?
Only one path of current is
Yeah,
going to
see,
flow.
whatever the current that is delivered by this source has only one path to flow. Either even for these that will be flowing. Say, suppose if this delivers 10 amperes of current, this delivers 5 amperes of current, a resultant of 5 amperes will be flowing in this path, right? Am I clear?
Yes, sir.
Now, so we assume that only 5 amperes is flowing through the circuit. We are least bothered about the individual values. We are only bothered about the current that flows in this path. We are not defining the capability of the source. We are just knowing the value of current which is flowing in the circuit. So now with this assumption, what's the values of value of voltage drop we can get here? It should be equal to VAB, right? Any of these should be equal to VAB. That's what it means, right? Since I can equate them, what's the value I'm going to get here? Is whatever the value I get here is equal to, should be equal to VAB. So find the values of this VAB.
We'll get 0, sir.
Don't equate them. Either take that value or this value. Equating itself is 0, right? Doesn't matter. VAB can see, VAB can be given as 28 minus I1 into R1, or it can be given as 7 minus I2 R2. That's what I said, right?
Yes, sir.
That's what we'll get 0, sir.
Which one?
If we substitute I1 is equal to I2 in that 28 minus 4I is equal to 7 minus I2 equation, we'll get I1 is equal to 7 amperes.
I1 is equal to 7.
7 amperes. Therefore, I2 is equal to 7 amperes.
Okay, let me clear this first. So write the KVL equation for this loop, starting from here. Where is this draw? Okay. So where do we start? We start from here, okay? So what's the equation we write here for this? Since I'm starting with minus, I take it as minus 28, right? Plus, since the current is flowing in this direction, I consider this to be plus and minus, right? So what is the equation I'm writing here? I into R1, right? Up to here, what's current is flowing in this direction, assuming that, so plus minus. So what's the value I get here? I plus I into R2 plus, what's the value I'm going, polarity I'm going to get here? Plus and minus. So what's the value I'm going to get here? 7 is equal to 0. Is that okay? KVL loop equation.
Yes, sir.
So what's the value I have here? 28 plus I is common for both. So what's the value of R1 is 4. What's the value of R2? 1 plus 7 is equal to 0. So what's the values I'm going to get here? 28 minus 7, you get it as 21. So I send it other side. So 5I is equal to 21. Is that okay? So I is equal to 21 by 5. What's the value I'm going to get here? 4.2. Is the current okay?
Yes, sir.
Okay. Now what's the equation? Previous equation I will remove it, right? So what's the equation for VAB? We considered either it should be 28 minus
I1 R1.
yeah, I1 R1. So what's the value of I1? What's the value of I you got? 28 minus, what is the value of I you are going to get? 4.2 into
4.2.
4. So what's the value you are going to get here for a voltage drop?
11.2
minus,
volts.
Yeah.
11.2 volts.
11.2 volts. So this is one condition. So what's the other value has to get for VB? What's the other condition you can write? So this is one way, one thing. You can also get through other one. That's what I said, right? Since it's a since it is a parallel circuit, parallel system, the voltages across A and B should be remaining same. So whatever the value I got it for 11.2 across this branch, it should be same here, isn't it? So what's the equation we were talking? It should be
7 minus
something like 7 minus
I2 R2.
I2 R2. So what's the value you are going to get? 7 minus 4.2 into 1. But what is happening? What's the problem here is the current is assumed reverse, right?
Yes, sir. That
What are the
We should
current that
take
is coming
plus,
out
minus
here?
4.7
So you can take it as
plus.
minus I2 or you can take add it.
plus.
So
Yes,
if I
sir.
add it, we get the same value as 11.2 volts. So in both conditions, the value of VTH is same, right? Or it should be same, right?
yes, sir.
So now we got the value of VTH as VTH is equal to VAB is equal to 11.2 volts. Is that okay? Now tell me the value of RTH by directly looking at it. What is RTH?
5 ohms.
5 ohms.
RTH is equal to what is the equivalent circuit? These two are connected in parallel, right? 1, 2 across AB. I shorted the this is A, this is B, right? I shorted the sources, right? So this will be the equivalent circuit. What is that? 4 and 1. The same resistors which are series now, right, will become parallel when I'm looking into the circuit from A and B. Why? Because I'm just assuming that if I have a current flowing in here, it will be divided into two parts. That's what, right? Am I clear with this? How these two are connected? What is the equivalent resistance between these two? Uh, 36?
4 by 5, sir.
8.2.
Yeah.
4 by 5.
This is the same, right? So since when to find the value of RTH, what we have to do? We have to look into the circuit from these two terminals, right? That's what we are doing from the last class, right? So what you are trying to do? So simple way is to assume a current flowing in here. Let us see how the current is coming. How current divides here. So we can say that these two are in parallel. So what's the equivalent resistance now? RAB is equal to 1 parallel with 4, right? So what's the value you are going to get? 4 by 5?
0.8, sir.
Yeah, 0.8 ohms. So we got the value of VTH and RTH. So after getting the value of VTH and RTH, what is the next thing we have to do? Draw the equivalent circuit or Thevenin's equivalent circuit like this. So the circuit with dotted lines represents replaced by Thevenin's equivalent, having a VTH which is equal to 11.2 volts, having RTH connected in series which is equal to 0.8 volts, right? In series with 2 ohms. This is a resistor which we removed in the first case, right? So now I think we can find the value of I2. What's the value of I2 equation for I2 now? What's the equation you can write for I2 here? I2 is equal to VTH by total resistance. What is the total resistance? RTH plus RL. So what's the value you are going to get? 11.2 divided by what is the RTH? 0.8 plus 11.2 ohms. So what's the value you are going to get? 11.2 by 2.8 amperes. Is that okay? Is the value okay?
Yes, sir.
4
4
amperes.
4 amps.
The resultant will be 4 amperes. Is it okay with Thevenin's theorem? Yeah. If you are okay with this, just solve this circuit and post in the group. You have 2 assignments, one with the dependent source. Okay, bit confusing. You try to solve this, then I think your confusion, you will lose your confusion. Number 12, you just take the circuit, take a screenshot of it, right? Get me the values of VTH and RTH.
Okay,
Okay,
sir.
post them in the group. Let me see. Am I clear?
Yes, sir.
Fine. So let us wind up for today. See you in the next class. Fine.
Thank you, sir.
Thank you, everyone.
Thank you.
Thank you, sir.
Thank you, everyone.